Hey guys, Mr. Barnes here again, bringing another math video. This one on solving some trigonometric proofs or proving some trigonometric relationships. So these involve some of our more of our simpler ones like sine, cos, tan. Um, no double angle formulas or half angle formulas or anything like that, or sum and difference formulas. Um, so generally, what I like to do when I'm doing a question or a proof like this is if I have secant, cosecant, or anything like that in it, I want to try and put them in terms of sine. So even tan, I'll try to put in terms of sine. And again, you always have to choose what side you're going to start with. So if you look at this side, there's probably a little bit more we can do with it as opposed to over here. You know, we don't really, we can do a couple things with secant squared, but there's not a whole lot we can do with it. So I'm going to take this guy and I'm going to rewrite it in terms of sine and cos. And let's see, hopefully something will cancel out. So cosecant is the same as 1 over cos of theta. So I'm actually going to write left-hand side is equal to. So left-hand side is equal to, and that looks really messy. Let me try again. Left-hand side is equal to, so cosecant theta is the same as 1 over, not 1 over cos, 1 over sine. I always make that mistake. 1 over sine theta. Tan is the same as sine theta over cos theta. And secant is the same as 1 over cos theta. So now I've rewritten those as their trigonometric identities. So if you're wondering where all these are coming from, um, maybe you might want to just give Google to some that are out there. So really, cosecant is reciprocal identity is 1 over sine. Tan is the same as sine over cos, and secant is the same as 1 over cos. So now what I want to hopefully do is cancel some stuff out. So if I look here, I have a sine on top and a sine on the bottom, so I can cancel those two guys. So what I'm left with is a cos times a cos. So cos times a cos is cos squared. So 1 over cos squared theta. And well, we know that secant and cos are related, so secant theta is the same as 1 over cos theta. So secant squared theta is the same as 1 over cos squared theta. So I can take this secant squared theta and set it equal to here. So that's what we'll have. We'll have secant squared theta, just like that. And that's equal to our right-hand side. And our proof is done. So simple as that, guys. So that's what you got to try and do. So if you're given a situation where you have one of these proofs, try to get it in terms of sine and cos. And then try and get some stuff to cancel it. So let's try another one. So again, I have cotangent, I have secant, and I'm going to start with my left-hand side here because there's certainly a lot more I can do. And hopefully I'll change things in terms of sine and cos, and hopefully it'll work out for me. So I have cotangent, which is cos over sine. So cos x this time over sine of x. And secant is 1 over cos of x. Make sure you write in the x's and stuff too, guys. That's really important. Don't get sloppy. And then sine is just sine. I'm going to write it over 1 just to like sort of make it blend with everything else I have in top of in the numerator. And then I have cos of x. So hopefully I can get a few things here to cancel. So if you look here, my sines cancel. So I have a sine over here and a sine over here. So they cancel. So I'll multiply straight across the top. So that's good. And my cos cancels. So all I'm left with in the top is 1. So I'm left with 1 over cos of x, which we know as secant. We just talked about it in the last example. Secant x, which is equal to the right hand side. And that's it. We're done that proof. So again, guys, this stuff is not too complicated if you just try and really critically think about changing stuff in terms of sine and cos. Alright, so here we got a situation where we already have everything in terms of sine and cos. And we sort of need to, you know, get this to equal tan. So this doesn't look like it's going to be too easy of a task. Let's have a look at it and see what we can do. So the first thing I'm thinking, if I'm subtracting within one of these proofs, is common denominator. So if I want to get a common denominator here, what I can do is multiply this fraction right here by cos squared over cos squared. Or sorry, cos over cos. So my left hand side is equal to 1 over sine x cos x. And then I'm going to multiply this guy by cos over cos. So cos times cos is cos squared x. And then sine times cos is just sine cos. So I've got a common denominator now. And that's, so I'll just write everything over that common denominator. So the common denominator is just sine x cos x. So this guy right here is my Pythagorean identity, and I like to say it's kind of in the skies here. We should know that sine squared x plus cos squared x is equal to 1. So if I rearrange this and solve for sine x, sine squared x, what I end up with is 1 minus cos squared x. So this guy right here actually equals sine squared x. So sine squared x over sine x times cos x. I almost forgot the sign. Sine x cos x. So then what I can do is I've got a sine on bottom here, and I've got 2 on top, sine times sine, so I'm just going to get rid of that squared. So that leaves me with sine over cos. And of course we know sine over cos, so sine x over cos x, and we know that is the same as tan of x, and that is of course the right hand side. We are done our proof. So guys, there's 3 examples of some I don't want to call them difficult trigonometric proofs, but you know, all trigonometric proofs are difficult in a way. But there's some of your lower level ones using your Pythagorean identity and your few reciprocal functions and tan and cotangent. So I'll probably check out another one of my videos where I have some double angle formulas and sum and difference formulas, some more complicated proofs if you're looking for those. Alright guys, so thanks for watching, and I will see you guys in class. Best of luck.